All right, let's dive into something that sounds like it's straight out of science fiction, but I promise you it's very, very real. We're talking about the nature of light, hidden dimensions, and a discovery that could literally change how we understand the fabric of the universe itself.
So let's start with a question. What if the light that's all around us right now is way more complex than we could ever imagine? I mean, what if its tiniest particles, photons, aren't just defined by our three-dimensional world, but can actually hold information about dozens of other states, all at the exact same time? Because, get this, that's exactly what a team of scientists has just managed to prove. They've shown that a single particle of light can exist in a 37-dimensional state. Now, to be clear, we're not talking about 37 physical places you can visit. It's more like 37 different properties or channels of information that a single photon can juggle, all at once. And to understand how that's even possible, we need to take a quick trip. And that trip is into the bizarre, absolutely fascinating world of quantum mechanics. This is the realm of the incredibly small, where the normal rulebook for our everyday reality just gets thrown right out the window. You see, in our world, things are predictable. A billiard ball only moves because another one hits it, right? But when you zoom way, way down to the quantum level, the rules get weird. Particles can be mysteriously connected, influencing each other instantly, even if they're on opposite sides of the universe. And this mysterious connection has a name. It's called entanglement. The easiest way to think about it is like this. Imagine you have two coins that are quantumly linked. If you flip one and it lands on heads, you know instantly that the other one is tails. It doesn't matter if the other coin is in the next room or in another galaxy, the connection is instantaneous. This whole idea was so strange that even Albert Einstein couldn't really wrap his head around it. He famously called it spooky action at a distance. He was convinced there had to be some hidden, local rule that explained it all away. But, as it turns out, the universe is even spookier than he could have imagined. So Einstein's skepticism really pushed scientists to ask a huge question. Was this spooky action for real, or was there some hidden information, some local rule, we just couldn't see it? They needed a surefire way to prove it, and that led them to a brilliant and kind of mind-bending thought experiment. The challenge was massive. How in the world do you prove that these connections are truly instantaneous? How do you show it's not just some secret information the particles agreed on from the start? Basically, how do you prove the universe isn't playing by our simple local rules? And the solution came from something called the GHZ Paradox. It's an incredibly clever thought experiment that basically sets a trap for reality. It predicts that if the universe only follows local rules, if there's no spooky action, then doing a certain measurement will give you a result that's just mathematically impossible. We're talking like proving 1 equals -1. It just can't happen. So here's the genius part. If you run the experiment and the math doesn't break, if you avoid that crazy contradiction, well, you've just proven that the universe isn't local. You've proven that Einstein's spooky action is a fundamental real feature of our reality. And that brings us to the experiment itself. A team of brilliant researchers decided it was time to take this idea out of the textbook and actually test it in the real world, pushing the very boundaries of what we all thought was possible. Now, a challenge this huge was not a solo mission. This was a major international effort, bringing together the incredible expertise of research teams from the Technical University of Denmark and the University of Science and Technology of China. And to pull this off, they needed some seriously advanced tech. At the heart of it all was a cutting-edge device called a Time-Domain Optical Processor. The best way to picture it is like an incredibly precise control panel for light itself, allowing them to guide and manipulate individual photons with just breathtaking accuracy. The process itself was like a 4-step masterpiece. First, they create the photons. Then, they entangle them to create that spooky link. And next comes the truly mind-bending part. They use their optical processor to split this single entanglement across a complex 37-dimensional state. All that was left was to measure the outcome and see if reality would break the old rules. So, the big question, after all that incredible work, what did they actually find? Did the universe follow the simple, local rules that Einstein kind of hoped it would? Or was reality a whole lot stranger? Well, let me tell you, the results were not just a success. They were a landmark discovery, one that opens up a whole new universe of possibilities for science and for technology. The results were completely conclusive, and yeah, they were record-breaking. They successfully demonstrated quantum entanglement across a staggering 37-dimensional state. It's the most complex quantum connection ever achieved by humanity. The math held up, the spooky action was real.
So what are the big takeaways here? First, they confirmed the GHZ paradox isn't just a theory, it works. That means our universe is fundamentally non-local. That spooky connection is absolutely real. They also showed these quantum effects are way more robust than we'd ever been able to measure before. And ultimately, it just reveals a universe that is profoundly more complex than we ever knew. Okay, so this is all incredibly cool physics, but you're probably asking, why does it actually matter? Well, because being able to control entanglement in so many dimensions isn't just a scientific party trick, it's a powerful new tool. It's like discovering a new natural resource, but on a quantum level. And this breakthrough isn't just theoretical, it's the foundation for technology that could change everything. By controlling these high-dimensional states, we can build quantum computers powerful enough to solve problems we see as impossible today. We can create communication networks that are secured by the laws of physics themselves, making them truly unhackable. And who knows, this might even lead us to discover entirely new laws of physics. What this discovery really proves is that the universe around us is anything but simple. A tiny single particle of light has shown us a hidden, complex layer of reality that we never even knew was there. It just leaves you wondering, right? If a single beam of light can hold 37 dimensions, what other profound secrets is the universe hiding, right in plain sight?